Good morning, guys. We're going to go through just a couple parts on here today and then call it a day, so it should not be too long of a video. You use the Pythagorean theorem to calculate the distance between 2 points on the coordinate plane. Your method can be written as a distance formula. The distance formula, I'm going to highlight so you see that, states that if x1 and y1 and x2 and y2 are 2 points on the coordinate plane, then the distance d between x1, y1 and x2, y2 is calculated using the given formula. So this is the given formula right here, what I'm highlighting. Okay? So what they're saying, x1, y1 is a point that the x and y point, such as here, and the x and y point, second point, such as there, if you take those points and set them as x1 minus x2 and y1, or I'm sorry, I said it the other way, y2 minus y1, and put them in the parentheses like that and fill in this exact equation, you would get the distance between. So for example, if this was 1, we'll go 2, 3, and we'll go 6, 8. So if I go right like this as x2, so that'd be 6 minus 2, parentheses squared, with the square root under, plus parentheses 8 minus 3 squared, like that, we can figure out that this would be 4 squared plus 5 squared. The square root ends up getting rid of these signs, so it ends up being 4 plus 5, which is 9. Number 6, when you use the distance formula, it doesn't matter which point you identify x1, y1, and which point you identify x2, y2. Explain your reasoning. So for 6, for this, you just end up saying, no, it does not matter. So you can say, no, once I square the differences, the values will be the same. So it does not matter if I put this is x2 and y2 and this is x1, y1. The only thing you have to do is wherever you put x1, y1 has to go to that next point. It can't be x1 and y2. Okay? So, can quadrilateral EFGH be classified as squared? Justify your reasoning. Okay, so what we have to do is this. We're going to pick points. So FG. So I'm going to write right over here. FG is going to be point 0 for x. I'm sorry, not 0x. 6x and 0y. Point, I don't know why they call it FG. I'm sorry. That's F. E is going to be x is 2, y is 3. G is going to be x is 3, y is negative 4. And H is going to be negative 1, negative 1. Okay, so now we're going to do some math on here. So we're going to figure out FG first. Okay, so FG we're going to do is square root. And we got to do, we're going to pick F first. So F was X, I'm sorry guys. Ooh, I just did a brain fart here. So for that we're going to put 6 in here. Minus, we're going to do G, which is 3. Then we're going to put 0 And because that's going to be a negative and minus, so we're going to do a parentheses like this inside of parentheses. Otherwise, you get confused on the negative signs. Okay? So that ends up becoming down to, this is going to be 3 here, plus a negative, ends up being, making those a positive like that. Okay? Which is funny because they got it kind of wrong on there. They have it marked as a negative. So we'll just put it as a -4, even though it's technically not correct. And I lied on earlier where I said square root gets rid of it. It doesn't, but what we're going to end up doing is this. So 3 squared is 9 plus 4 squared ends up becoming 4 times 4 is 16. We add those together, ends up becoming 25. Square root of 25 is 5. So that's 5 units of distance. Okay, so now we're going to pick G to H. Okay, so G to H. We're going to pick G first. So we're going to use G as our X. 3 minus H, -1 squared plus -4 minus -1 squared like that. What you end up getting comes down to be add those together, so 4 squared plus, add these together, ends up making that to be -3 squared, which gives you 16 plus plus 9, because a -3 times -3 gives you 9, which add them together again gives you square root of 25, which at the end gives you 5. So we know that this is 5 points across, that's 5 points across. So now we're going to try side HE and see if that works. And yes, this is the work that you would have to do to prove that this is correct. So again, square root, and we're doing H to E, so it's going to be X is -1 minus 2 squared plus -1 minus 3 squared. -1 minus 2 ends up giving us -3 squared plus -1 minus 3 gives us 4 squared. Sorry, -4 squared. So you square that, gives you 9 plus 16. Add them together, square root 25. Square root of 25 gives you the answer 5. So that's 5. If all 3 sides are 5, this side will end up being 5 as well. So this is a square. Okay. We're going to do 8A, and I'm going to stop there for today. Okay? Because this is a lot that we're doing right now. So it says, use the distance formula to calculate distance between each pair of points. Round your answer nearest tenth if necessary. Show your work. So we know that's x, y, x, y. Okay, so square root. We're going to do x2, so let's just do the 3 minus 1 squared plus 7 minus 2 squared. 3 minus 1 gives us 2, plus 7 minus 2 gives us 5. 2 times 2 is 4, plus 5 times 5 is 25, which gives us 29. We have to square root 29, so we go to our fancy-dancy calculator. If we hit second and the x2 key, right where you see me holding I'm going to delete a couple of these. But right where you saw me hold, it gives us our square root symbol. Now we just type in 29, hit enter. Oh. Let me try again. 29, enter. You just hit it once. I had it typed in twice. I'm sorry, guys. Hit 29, enter, and they asked us to round our work to the nearest tenth. So when we look at this, our nearest tenth is the first number after the point. So because it's 5.38, we have to look at that second number to tell if we're going to round the first number, the 3, up or down. So because it's an 8, we're going to round it up, so it's going to be 5.4. So square root of 29 is 5.4. So that's how many units that is away. That's where we're going to stop today. Tomorrow we'll pick up and do this part here and finish it out.